So we're looking at the cosine rule for angles. All right, so we've got the cosine rule already. We know that that is, what have we got? A squared, is that right? A squared is equal to b squared plus c squared minus 2bc cosine of a. Okay, and we've been using that already to calculate not angles, we've been using that to calculate missing sides. So if we rearrange this, which you've just had a go at, all right, so we'll do that again and we'll have a look and see what we do. So I'm going to subtract b squared and c squared from both sides, okay? So notice that what I've done, if I do that, I get a squared minus b squared minus c squared is negative 2bc cosine of a. And I'll just note down over here that I have subtracted b squared and I have subtracted c squared. So it's a little note to show what we've been doing. Now to finish this off, to get cosine of a on its own, what we do is we're going to divide both of these by negative 2bc. Right? You can kind of see that works nicely because it's the cosine of a times negative 2bc, so I can divide through by all of that in the one go. And typically what we do is we just write that cosine of a, the subject of the equation, we put on the left. And I've got a squared minus b squared minus c squared all over negative 2bc. Now because it's messy having a negative at the bottom, what we'll do is we'll multiply the numerator and denominator by negative 1. So effectively what we're doing is we're doing this. We're going over negative 1, or times negative 1 over negative 1. And if we do that, then I get positive b squared, positive c squared, negative a squared, and positive 2bc. And therefore the cosine of a is equal to that. So that is the cosine rule, and that is for angles. Okay, so let's try one and see how that all works out. So here's an example to have a go at. That's a nice triangle. And I'm trying to find x here, and this is 7 meters, 11 meters, and 9 meters. So just grab a colour of pen. So first of all, can we do that? And yeah, we can, can't we? Because the thing we're trying to find, I'm going to make that capital A, and then that must be A, and this is B and C there. And again, it doesn't matter which way around we get B and C, both of them will work out. So I think that works because all of the parts of our equation are there. That's what I'm trying to find. And then have I got B, C, and A? And we do. So really when it comes to finding angles, all we need is 3 sides, okay? We don't need another angle. We just need 3 sides, which we've got. And notice that that's what we've got. We've got 1, 2, 3 sides, all 3 sides of the triangle and one of the angles. By the way, we can use the equation also to find that angle or that angle, okay? So you can complete that and say, well, let's work out all the angles, and then we'll do this one, and then the last one we can use as well, or we can just subtract from 180, and we would have them all there. Right, let's go through the process of doing this. 1, label the triangle, okay, so we've done that. And 2, write out the formula. Okay, well we better do that. So cosine of A, B squared plus C squared minus A squared over 2BC. So we've done that, done this and done that. So 3 is we substitute. All right, so we're going to substitute everything in that we know. The cosine of A, of course, that stays because that's what we are trying to find. So we decided B is going to be 7. So 7 squared, C is 9, 9 squared, minus 11 squared over 2 times 7 times 9. Okay. Now at this stage you can go ahead and work that out on your calculator, and that answer you can then do inverse cosine of A on. Alright. Or, this is what I prefer to do because I'm lazy, is that this saves just one extra step on the calculator. Remember, we're going to do the inverse cosine of the answer that we got, but rather than mucking around with that, I can put the whole thing on my calculator. So 7 squared plus 9 squared minus 11 squared over 2 times 7 times 9. Okay, so we've done the substitution. Really then, there's a little bit of rearranging with that. And then really calculate. You don't always have to do that either. If you work that out on the calculator, you can just do inverse cosine of the answer. But on the calculator, so shift, cosine, fraction button. I know that 7 squared is 49, that'll save me some time. That's 81 minus 121. You can just put all those squares in if you prefer. And then 2 times 7 is 14, so we're going to go 14 times 9. And close that off, and press equals, and I get an angle of 86 degrees, okay? Alright, so that looks fine. In fact, it doesn't look fine because I had a different answer the last time I did it. Let me just check that I've done that right. I think so. We'll stick with that. Is 85, is that sensible? Yeah, it's not too bad. That we'd expect this to be larger than 60, wouldn't we? So I guess that's okay. So 49 plus 81 minus 121, and that is, yeah, we'll stick with that. Okay, so I've got 86 degrees.